Hey there. Let's talk about representing negative numbers in binary. We're going to use a system called 2's complement, which is going to allow us to represent signed integers, which means there will be a positive sign or a negative sign on the integer, and we'll still be able to do it in pure binary. So let me talk a little bit about what I mean first here. Okay, so what do I mean by signed and unsigned? Okay, so if I just type the number 14 by itself, that is that's an unsigned integer. We don't really know if it's positive or negative. Like, do we know that it's negative 14 or do we know that it's positive 14, right? So the sign is what lets us know if something is positive or negative. Okay. So if I type a number in binary, let's just do a pure binary number. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 bits or just 1 byte. If you know how to convert binary to decimal, you probably recognize right away that this is just the number 0. Even if we add a couple of bits here, that's just like the number 3. And so this is the number 3. But so far, if you haven't learned signed integers in 2's complement or in binary, then you don't really know that there's a sign. You just kind of assume that the number is positive. By default, if you're not using 2's complement and you're just saying like, well, let's just do a bunch of binary digits, then yeah, it's a safe assumption that the sign is positive. But we'll use 2's complement, which starts with the idea that the highest bit, the leftmost bit, the bit with the the most power, that's going to turn into the sign. That's going to turn into the plus or the minus. So like, plus or minus is going to be, the sign. So this means that we have to decide, does a 0 mean positive or does it mean negative or what means what? So in 2's complement, we'll say that 0 is positive and 1 is negative. So you can see right here that we're still actually representing the number 3, but it's positive 3 for sure because this sign bit right here is 0. That's positive. Once we decide to represent 2's complement, then we can say that for sure. On the other hand, if we put a 1 here, then we definitely know that this number is now negative. However, we don't actually know that it's a 3 because the numbers don't work out the same anymore in 2's complement. So the positive numbers, they will mostly look the same. The negative numbers, they'll look a lot different, but they'll still be valid in order, in terms of us being able to add them together, subtract them from each other and things like that. So 2's complement is pretty cool. Let's do, let's see, what else can I tell you? Oh, one thing to understand is that in an 8-bit unsigned integer in binary, let's say 1, 2, 3, 4, 5, 6, 7, 8. Let's say unsigned bits. Maybe I'll just put maybe just some V for value. All the bits are values. That means the range is 0 to 255 with 256 total combinations. But if we want to use a signed number, then we'll actually have the sign bit be the first bit, and all the rest will be value bits. 1, 2, 3, 4, 5, 6, 7. In this case, the range kind of goes down, because if you think about it, every single bit, represents it helps towards the highest possible value that you can represent. If we're using the leftmost bit, then for an 8-bit integer, that's 128. That's a value of 128. So we lose a lot off of the maximum integer that we can represent. So the range here is, I think it's negative 128 to positive 127. Just keep in mind, you'll have to trust me in terms of why is the negative 128 bigger and the positive 127 smaller, but that's just the way it is. So that means we only get these value bits here. And if you look at it real fast, you can see that, let's see if I can do this quickly enough without screwing it up. We'll say 127 minus negative 128, I guess. That's 255. And then also a 0. But in terms of positive and negative, the way this is going to work out is the 0 will probably show up twice because, well, that's just the way it is. Notice how I can represent 255 possible combinations with 7 bits. Normally you would have a range from from 0 to positive 255. And in this case, we're just, losing our range. But we can represent negative numbers. Anyway, okay. So let's talk about doing an example real fast. Let's see, I've got like a little notes to tell me what I should do. Okay. It's important to understand that normally when you have, let's say you have like an 8-bit number and you go 1, 2, 3, 4, 5, 6, 7, 8. And then you have 2 bits right there. And so this is like, positive 3. If you wanted to copy that number into more bytes, like for example, if you wanted to take a 2-byte integer and have it copy the value of a 1-byte integer, then it's pretty easy. You pretty much just pad zeros to the left. You'll say 1, 2, 3, 4, 5, 6, 7, 8. That would work perfectly. However, if you did this with a negative number, let's say that we have a negative number. I'm going to put some other random pattern so that you don't think it's the 3. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 total, so I'm going to make that a 1 and then get rid of that. So we have like 8. Negative number. If we were going to copy that negative number from 1 byte into a 2-byte integer, then we would copy paste it to start, but then you'd have to pad with 1s to the left. 1, 2, 3, 4, 5, 6, 7, 8. Same negative number, more bits. So be very careful about how you pad. If you're padding an unsigned integer, then yeah, you'll always pad zeros to the left no matter what is happening. But if you're padding a signed integer, then you have to pad differently. When you're padding a signed integer, you have to pad with whatever the highest bit is. So in this case, the highest bit was a 0, so we do pad with zeros. But then in this case, the highest bit was a 1, so we have to pad with 1s. If you don't do that, you're going to end up with a number that doesn't actually make sense. Okay, so now let's work on actually converting a number to a negative number, or representing a negative number in 2's complement. Okay, so I'm going to write 2's complement here, and then let's start off with the number negative 109. Okay, how do we do this? The first thing is convert it to its positive form. Take the absolute value. Okay, so we'll really just take positive form here, and that's just going to be positive 109. Okay, no problem. I'll say start with negative 109, and then we'll take the positive form 109. Now we'll convert it to binary. Okay, this is not a video that teaches you how to convert to binary, so I'm just going to try to do this in my head real fast here. It's going to be, let's see, we got 8 bits. We'll use just 8 bits to store the number. And because, it's low enough and I don't want to use that many bits. So it's odd, so I can add a 1 there, but maybe for now I should find the highest bit that is less than the actual number. So this is the 128 bit right here. So that's going to be a 0. This is the 64 bit, so I'm going to put a 1 there. And I'm just going to say, maybe like, this is like maybe not the smartest way to do it. I'll say 109 minus 64, because I put a 1 there. And then 45, so now this is 32. That's less than 45, so I'll put a 1 there. And then it's going to be minus 32. So it goes from 45 to 13. So then that was the 32. Okay, so 128, 64, 32, and then 16. Is 16 less than 13? No, it's not. So we'll put a 0 here. And then the next one is going to be 2, 4 is going to be just 4. 4 is definitely less. So I'll put a 1 bit there, and then I'll subtract 4. And then 1, 2, 4. Oh, wait a minute. 1, 2, 4, 8. Sorry, that was supposed to be subtracting 8, because that was the 8-bit. Then I want to get 5. So here is the 4-bit. So I put a 1 there, and then I'll just put a 1 here because 4 plus 5 is equal to, 4 plus 1 is equal to 5. So let's see. It is, let me just double check here. Let me just double check my conversion real fast. It's going to be the 1-bit plus 2, 4 plus 8 plus 6, 32 plus 32 plus 64. Did I get 109? Yeah, okay, so I guess I did it right. So convert to binary, and that's going to be this. The next thing we'll do is we will invert the bits. I made a little edit jump here because I inverted the bits incorrectly on the first try, which is sad, but hey, it happens. The next thing we'll do is we'll invert the bits. So basically, we take this original sequence here, and I'll just turn every single bit, I'll flip it. I'll flip 1s to 0s, and zeros to ones. So I'm going to go 1, 0, 0, 1, 0, 0, 1, 0. Okay, so now we have this number. Invert the bits. Then we just have to add 1. So we'll add positive 1 to that number in binary. And you can tell right away that it's just going to be a 1 there at the end. But sometimes that might not be the case, because what if we already had a 1 there and we had to add 1 to that? Well, we'd add 1 to the right side and it would, turn into a 0, and then it would carry a bit to the left. That would become a 0, and then the carry bit would show up all the way over there. So I just want you to be aware of the fact that when you add two binary numbers together, you have to be careful. You have to add them the same way you would add decimal numbers. For each digit's position, you have to add the two numbers together, and then if they overflow, then you just kind of wrap around to the lowest number again, subtracting the highest value, or sorry, subtracting the base. Like in decimal, if you add 9 and 9, the answer is 18, but you're not going to write 18 in that one position. You're going to subtract the base, which is 10, so it'll actually be 8, and then you'll carry the 1 over the next position. So it's like 9 plus 9 is equal to 8, carry the 1, right? So we'll do the same thing in binary. We'll say, if we ever get a 1 plus 1 when we're adding, the answer will be 2, but then we subtract the base, which is 2, so the answer is actually 0, carry a 1 bit. Keep that in mind. I'm just going to write it all out for you so you can kind of get a little bit of practice. It's important to practice this because it's easy to get wrong. I'm going to put a bunch of dashes up at the top to represent carry bits. And I'm going to say we're going to add, one number plus another number, put a little plus symbol over there just to try and make sure we do it the right way. Okay, so how do we add these? Well, we'll just go to the right side. 0 plus 1 is 1, no carry bit. 1 plus 0 is 1, no carry bit. Then we got a couple zeros here, no carry bit, of course. 1 plus 0 is 1, no carry bit, and then a couple zeros, and then another 1 with no carry bit. Okay, so, we could have done that pretty easily, but, well, now we're getting a taste for binary addition that might be harder later. So we'll just do that for now. And now this is the 2's complement representation of negative 109. I'll say now we have negative 109 is equal to that. Notice how the leftmost number, the most powerful bit is a 1. Remember, 1 always indicates negative. So when you're looking at it, if your leftmost bit turns out to be a 0, then you probably did something wrong, or you had an overflow maybe. And again, if we were going to try to, send this number into a 2-byte number or an 8-byte number or whatever, then we would just have to pad with the sign bit. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put a space to help my brain. So this is the way it would look in a 2-byte number. This is the way it would look in a 3-byte, a 4-byte, and 5, 6, 7. How many? 1, 2, 3, 4, 5, 6, 7. Okay, one more. This is what it would look like as an 8-byte number or a quad word, 64-bit number. Yeah, okay, so now we know how to do negative 109. Okay, so now let's do a number that's a little bit smaller. Let's do negative 29. So let's say convert, or how about represent negative 29 in 2's complement. Okay, so first we, get the absolute value. So just 29. And then we have to we have to get that into binary. So next, convert to binary. And I'm going to start with zeros, 1, 2, 3, 4, 5, 6, 7, 8. For this video, remember, we're choosing to use 1-byte integers, but if you wanted to do a bigger one, or you had to do a bigger one, then just, keep that in mind. Okay, so 128 is not smaller than 29, 64 is not, 32 is not, 16 is though, so I'll put a 16 bit there, and I'll just subtract 16 from 29. 29 minus 16. Now we've got 13 left. So 64, 32, 16, 8. Okay, so now I'm going to put a 1 bit there, and I'm going to subtract 8 from the remainder, and then we got a 5, which is pretty easy to do. 8, 4, and then a 1. So now we have 0, 0, 0, 1, 1, 1, 0, 1. That's the binary number, the positive or unsigned representation. Not AKA, just positive or representation. So now we'll add 1. Positive 1. And let's try to do this the right way so that we can practice carry bits with addition a little bit. Notice how this 1 is already there on the right side. So we're gonna have at least 1 carry bit for sure. So then I'm gonna go doop like that. And then I'm gonna say that we have like, what is the result? Put a positive sign there. And then I'm gonna put a bunch of dashes just to remind me to do my carry bits, because I can forget that pretty easily. So the first thing is we add 1 and 1. The answer is 2, but we can't put the number 2 here because it's binary. Instead, we need to subtract the base, which is 2. So 2 minus 2 is equal to 0, but then we have a carry bit of 1. So I'm going to put a 1 there. The first carry bit will stay as a dash for this whole exercise, because you're not going to carry on to the first digit. So now we have what would have been just 0 plus 0. Now we have 1 plus 0 plus 0. So that means this is going to be 1, and then the carry bit is just going to be 0 because we don't actually carry anything. So then we have 0 plus 1 plus 0, so that's going to be a 1. And then 0 carry bit, and then 0, 1, 0 is just going to be 1. And then there's going to be no carry bit, and then 0, 1, 0, again a 1, no carry bit because we didn't actually overflow, and then just zeros. So 0, 0, 0, and then I'm just going to put zeros here. Okay, so now we have successfully added. I blew it. Totally blew it. I always forget steps. Don't forget the steps. This is a good lesson. I'm going to leave this in the video because I want you to see that everybody makes mistakes, and you got to practice, 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 especially before you have to actually do this in real life or for a quiz or an exam or something like that. Next, convert to binary. Before you add 1, I'm going to just remove this. Oh my gosh. Next, flip the bits, which is going to be 1, 1, 1, 0, 0, 0, 1, 0. Okay. So now we take this bit flipped number and we will add 1. So that's going to be 0, 0, 0, 0, 0, 0, 0, 1. Oh, it's too easy. Maybe I got excited and I thought, oh, it's carry bit time. But even though the last addition that I did was wrong because I forgot to carry or flip the bits, you still at least saw a little bit about how to carry the bits, right? Okay. So it's just going to be 1. Let me start from the right side. 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 1. Let me just double check here. 1, 1, 1, 0, 0, 0. Okay. So I got that. Now we have negative 29 in 2's complement. Again, notice if we actually tried to add those numbers up to be like an unsigned binary number, they're not really going to make sense because this is like 64 plus 32 plus 3. So what would that end up being? Let's just double check here. 64 plus 32 plus 3, 99. That's not actually the number, but the number is 29. So keep in mind, you can't just look at this and know what number it is unless you're like really, really practiced. Okay, and again, notice that the number is 1 at the very left, indicating that it's a negative number. Now let's look at how to subtract one number from another using 2's complement. Okay, so what I want to do is I want to subtract, let's say, 29 from 109. Okay, so let's subtract, and I'll just say 109 minus 29. And how I would do that is basically I'll start by just taking 109. Let's see, convert to binary. So I'm just going to copy paste that number. So 109 is this, and then 29, take the positive version. It is just, let's see, before we flip the bits or anything, let me make sure that I grab the right one. Invert the bits. Okay. So positive 29 is this number. Whoops. Let me put parentheses around that so it's easy to tell, and then I'll put a positive sign there. Like that. Maybe like that. Nope, 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 nope. How about this? Okay, so now we have both of these numbers in positive form. So now, if we added 109 plus 29, that wouldn't be the problem that we're trying to solve. If we added 109 plus negative positive 29, that would be what we wanted, right? Because really, if you're subtracting, I'll say AKA positive 29 plus negative 29. All we really need to do is invert the 29, and then add the result to 109. So that means we'll turn positive 29 into negative 29 using 2's complement. I'm not going to go through the steps again, but basically, I'll put it there. But basically, that's negative 29. So say positive 129 is equal to what I just put up here, and then negative 29 is equal to, maybe I should do the parentheses again for clarity, is equal to this. Okay, so you can tell that positive 29 is pretty different from negative 29, but now we have both of those numbers. So let's see, 0, 1, 1, 0, and then we're ready to add. Okay. All we got to do is add them together. Next, add them together. Maybe I should write the steps up here on top. Positive versions of both. Whoops. Convert 29, positive 29 to negative 29 using 2's complement. And then next add them together. So then I'm going to copy paste the bits here, and it's going to be this plus this. We'll do a positive plus sign just to remind ourselves that we are actually adding. And then I'm going to put a bunch of placeholders for sign bits up at the top. And now we'll have a little bit more fun adding numbers together. Maybe I'll drag this down. Oh my God. Oh, there we go. Okay. So I'll start with the one on the right, the position on the right. That's going to be 1 plus 1 equals 2, but then that's an overflow, so I'm going to subtract the base, so it's going to be 0. And then don't forget to carry the 1. Oh, cool, more interesting. So we have 1 plus 0 plus 1. That's going to be another 2 carry the 1. Sorry, that's going to be another 2 minus 2 carry the 1. So it's going to be 0 and then carry the 1 again. So I'm going to put the carry bit up there. And then again, we have 1 plus 1 is equal to 2. So it's going to be 0, carry the 1. Again, 0, carry the 1. And then finally, we don't really have a carry bit. So we'll just have like a 1. And there's no carry. So it's going to be, carry a 0. And then we add these two together. So it's going to be a 0, carry the 1. And then now we have a 3. Oh, that's kind of nice. So this is an interesting edge case, kind of. 1 plus 1 plus 1 is 3. But if we subtract 2, the base from it, 3 minus 2, it's going to be 1, not 0. So it actually is going to be a 1, and then carry the 1 on top of that. Then for here, let me space this over a little bit so that I can illustrate what's going on a little bit better. We're going to have 1 plus 0 plus 1. That is definitely going to be 0, and then carry the 1. But there's no bit where that carried 1 can show up on, right? So that 1 overflows. It falls off the edge. If this was a bigger number, then okay. If we had more bits to this number, then sure, we would just keep carrying over to the left. But remember, we said before that when we have a very big number, let's see, if we have like a negative number with more bits, it's just 1s all the way to the side. That will actually help us make sure that if our final number is actually going to end up being positive, that everything kind of like dominoes, like carry the 1, 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 all the way until one of the 1s falls off. Think about it. So anyway, this 1 just is gone. We don't really care about it anymore. The result is going to be just only 8 bits because that's the number that we started with. 0, 1, 0, 1, and then a bunch of zeros. What is, the final answer? Let's just compute this real fast to decimal. So this is 128 and then 64. So it's going to be 64 plus, not 32, but 16. So 64 plus 16, that's going to be, 16, that's going to be 80. And now we just have to ask ourselves again as like a final step to double check yourself to make sure that you understand what you're doing and that you got it right, is just punch up 109 minus 29, just to make sure. 109 minus 29. Whoops, what happened here? 109 minus... Oh, I think I stole my subtraction key for the annotator. 109 minus 29 is 80. So again, if you're trying to write something down to do some work at work or, taking an exam or something, you definitely want to double check yourself in several ways. As you can tell from this video alone, I got one of these things wrong because I forgot to input the bits as a step before adding 1. So, your final step should be actually trying to add 2 numbers together or subtract numbers or whatever you're doing to make sure that you got the binary correct. So let's see. I guess maybe your first indication that the result was going to be positive would be that there's a 0 there. And just, as a sanity check, you look at the top and you're like, well, I was going to subtract a small number from a larger number, so the result should probably be positive, right? Like 29 is like way lower than 109. So it should be positive, which means the final result should have a 0 at that leftmost position. Okay, so that's 2's complement, how to convert numbers from positive to negative in 2's complement, what the sign bit means and all that stuff, and how to perform subtraction via 2's complement. I hope you enjoyed this video. Thank you for watching. I hope you learned a little bit of stuff and had a little bit of fun. See you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.